So I'm going to be explaining oxidation numbers. So there are 7 rules in total I've got from the AP Daily video that the College Board provides, and these are the 7 rules. So the first one is that the atoms in elemental form, such as just H2, Fe, like these ones, have an oxidation number of 0. Number 2, monoatomic ions, so the ones that are just like single, have an oxidation number that equals the charge. So lithium plus, so it will be a charge of +1, this one will be a charge of -2, this one a charge of +1, this one a -1, and this one +2, and you get the idea. Number 3, oxygen is most of the time it's a -2, but the exception is when it's in peroxides. So a common example would be hydrogen peroxide, H2O2. In this case, because H is a +1, that I'll explain in number 4, there are 2 H's, so it's going to be a +2 in total. So for this whole thing to be neutral, which I will also explain down here, in neutral compounds it equals 0, oxygen 2, O2, has to be a -2, and therefore that makes this oxygen, a single oxygen, a -1. So that would be an exception. The next one, hydrogen, that I've mentioned above here, when it's with a metal, it's a -1, and if it's with a non-metal, it's +1. In this case, since it was H2O2 and O is a non-metal, H was a +1. And H2 in total was a +2. Next one is fluorine. Fluorine is always -1, so just think of it like this. And the sum of oxidation numbers in neutral compounds is equal to 0. So in this case, if we look at H2O2, this is just a neutral compound. We don't see any charges up here, like a negative or a plus something. So we can consider this as a neutral, and we had to make it add up to a 0. The charges had to add up to 0, right? Because it was a neutral compound. And the last rule is that the sum of oxidation numbers in polyatomic ions is equal to the charge. So we'll be looking at examples straight away. So this one, we would be trying to give these compounds their oxidation numbers. So in the case of C, we don't know for sure, but we know for sure the hydrogen. So because hydrogen is with a nonmetal, C, we are going to give it a +1, as we've seen above here. So this is a +1, but because there are 6 of them, they are in total a plus of 6. And because of this rule, that the neutral compounds have to add up to 0, then 6 carbons will have to equal to a -6, which makes 1 carbon a -1. So on the top row, we're just going to be writing the charges of a single element, and on the bottom, the total of it, okay? The next one is O2. O2 is a neutral compound, as we've seen on here. It is in elemental form, so the oxidation number is 0. So in this case, we're just going to write 0 and 0 in total as well. In this case, O2, 1 oxygen is according to 1 oxygen, we know it has a charge of -2. And where we get this from is this rule. Oxygen most of the time is -2. So we're going to give -2, but because there are 2, we're going to have -4 in total, which if we want to make this whole compound neutral and add up to 0, we're going to have to give the carbon a +4. And the last, H2O, we're going to give the oxygen a -2. There's only 1 oxygen, so -2 in total. The hydrogen, since it's bonding with a nonmetal, we're going to give it a +1, and there are 2 of them, so it's a +2. So now, if we look at this, we're going to see that the oxygen, this is the carbon. So the oxygen before was a 0, but it became a -2. So oxygen was a 0 and it became a -2. And for the carbon, it was a -1, but it became a +4. So the carbon was a -4, but it became a +4. So this one gained electrons and this one lost electrons. Gain is G, remember? So it's a reduction, and loss is Leo, so it's oxidation. So we can say that in this whole reaction, oxygen has reduced and carbon has oxidized. And if we compare the other ones, like H plus, H was 1+, and on the other side, H is also 1+. And we can compare it like that. Now, the next example. So, Br2, we're going to give it, since it's in its elemental form, we're going to give it a 0, and in total it's also a 0. For the OH, we know that O is a -2. So there's only one O, so it's going to be -2 in total. And for H, since it's bonding with a nonmetal, it's going to be a +1 and a +1. And we can see that it adds up to the charge, which is a -1. And the reason why this one adds up to -1 is because of this rule, where monoatomic ions oxidation number equals the charge. And on the other side, Br, since it's a negative, it's going to be a -1. Br, so we don't know about this yet, but we know for sure that oxygen is going to be a -2. But there are 3, so it's going to add up to -6 in total. And then if we want the whole compound to add up to a -1, Br is going to have to be a +5. And H2O, we know that when hydrogen bonds with a nonmetal, it's going to have a charge of +1, but since there are 2, it's going to add up to +2, and oxygen is going to be -2, so overall it is a neutral compound, which adds up to 0. Now, if we were to look at this, about how the oxidation numbers changed, for Br, it was 0, but it became a -1, so 0 to -1. And then for the Br again, we can see that it also changed from 0 to a +5. And if we look at the other things, like oxygen, it's still -2, hydrogen is still +1. So in this case, we're going to say that for this one, it gained electrons, right? So it is going to be since it's a gain, it's going to be G, so it's going to be reduction. And since this one had lost electrons, it's going to be Leo, so it's going to be oxidation. So in this case, this is a very special case where the same element has both reduced and oxidized. In this case, this can happen, and we can say that Br has both reduced and oxidized.